Sometimes in order to make the one-to-one property work, you have to change both sides of the equation, which we'll see that here in number 7. We have 25 and 125. What I notice when I look at those is they are both powers of 5. So I can change 25, that's the same thing as 5 squared. And then 125, that's the same thing as 5 cubed. Okay, so it's okay if we change both of them. Then we're going to multiply here. So we get, just write it over here, 5 to the 4x. And then that 3 gets multiplied to both of those. So we get 5 to the 3x plus 6. Now the bases are the same, so we can assume those are the same. So we'll keep 4x is less than 3x plus 6. Just subtract the 3x over, and there's our answer. We'll do the same thing here with number 8. Let's see. 8, the only thing that 8's a power of is 2. So we'll say that's 2 cubed. And then that means we need this as a power of 2. I guess I don't need parentheses on that one. So it's got to be 2 to the negative something, because that's how we get a fraction. So 2 to the negative 4th, I believe. All right, this needs to be multiplied. So this is going to become 2 to the 3x minus 6 equals 2 to the negative 4. Now that the bases are the same, we can use the one-to-one properties to say that the exponents have to be the same. And then we'll just finish solving. Wait, that was a negative 4. I just did that wrong. Sorry. Okay, I'm going to add 6 to both sides and actually get 2. So x is 2/3. Okay, one last one of these. We have 1/64 and 16. This one could be done a couple different ways. It can be done with 4s or 2s, actually. So 16 is 4 squared. And 1/64 is 4 to the negative 3. Okay. Or you could have also done that as powers of 2. You could have said that 16 is 2 to the 4th, and 64 is 2 to the negative 6, I think. Okay, so both of those ways would get you the same answer eventually. I'm going to stick with the powers of 4 because that's the one I started with. So we're going to multiply here. We get 4 to the negative 3x plus 6. Multiply here. We get 4 to the 6x plus 2. Now that the bases are the same, we can assume that the exponents are the same. So I'm going to add 3x to both sides. I'm going to subtract 2. And then finally divide by 9. So x is 4/9. Now, this is a fantastic method, okay? But I have a couple questions. Can we solve this one the same way? So the problem here is we have 3 to the x equals 8. There is no way to rewrite 8 as a power of 3. We can't get the same basis here. So we can't solve this problem using the one-to-one property. The one-to-one property is really nice, but it is very limited. It only works for special types of problems. So what I want you to do is think back to the what power worksheet. If you did the what power worksheet, we were thinking about this what power. What power of 6 gives you 36? We said 6 to the second power gives us 36. So what we're asking in the problem I just showed you is what power of 3 gives you 8? And we actually have a function for this. It's called a logarithm. So we call it a log base 6 of 36 is going to give us 2. And a log base 3 of x, a log base 3 of 8 is going to give us x. So that is what our next lesson is about, is learning about logarithms, because logarithms turn problems like this into something that we can solve. Okay, so that's what's coming up tomorrow. But for now, we'll just stick with the one-to-one property.